Welcome to MBA Classroom, and our topic for today's discussion is line balancing. Line balancing is the process of assigning proper number of workers or machines to operations in an assembly line so that the production rate requirements are met. Also, we need to minimize the idle time to a minimum value or to zero. And one more thing in line balancing is we need to ascertain that the workstations have equal or approximately equal time requirements. So that is line balancing, and this is an example for an unbalanced line where we have four different operators doing different operations, and the first one is taking 5 minutes to complete the operation, and he is piling up the work after his work. And the second operator is doing work for around 25 minutes, and the third is 15 minutes, and the fourth one is doing it for 10 minutes. And this second operator, who is operating for 25 minutes for one process, is the bottleneck here. And this bottleneck or the constraint overburden need to be distributed evenly so that the line is balanced equally. Okay, so that is the objective of line balancing. His work need to be shared with some other operator so that the line is balanced and the flow of the work, the flow of the process is maintained uniformly. And this is how we balance the particular line. So from the operator's 25 minutes, operator second's 25 minutes job, he is going to give or share the work with operator 1 who has got previously only 5 minutes job. Now the first operator will be doing it for 15 minutes, and the second operator another 15 minutes, and third 15 minutes, and finally fourth 10 minutes. So the operations gets uniform. It is going to be uniform time period for all the operators, and by redistributing the work. This is what we do in line balancing. And we need to understand some concepts in line balancing. We have some concept like cycle time, total work content, minimum number of workstations, and line efficiency. And cycle time is the total operating time available divided by the required output. And for one shift or for one day, the company may be producing a particular number of output, and we are going to divide that number with the total operating time available for operations. And the second one is the total work content, which is adding up all the task time of all the tasks in the particular production area, the operations area. So if there are n number of tasks, we are going to add the task time of all these n number of tasks. And next is minimum number of workstations, which is the ratio between total work content and cycle time. And finally, line efficiency. We'll use line efficiency to understand whether the workstations which we are trying to balance is highly efficient and it is up to the standards expected by the management. And line efficiency is equal to total work content divided by number of workstations into cycle time. And there are some rules to assign the task to the workstations, and the rules are longest processing time rule and longest following task rule. Longest processing time rule says assign the particular task which has got longest processing time. So if there are two tasks A and B, and A takes 5 minutes and B takes 10 minutes, assign B first because it is taking longest process, it is having longest processing time. So that is this first rule. And second rule is longest following task rule is there are two tasks A and B. Understand or count the number of following tasks from A and B. And for example, A has got 3 following tasks and B has got 7 following tasks, and this rule says you have to assign B first because it has got more number of following tasks. right? So these are the rules to assign task, and there may be some areas where we'll use heuristics to assign tasks to the particular workstation. And these are some of the examples. There are two examples shown here. Left side is another one example where we have got active task from A to H, and other tasks which follow A and finally end up in H are given, and the activity duration is also given. And we need to balance this particular project so that all the workstations are equally distributed with time. And then the right side also another project is given, and we have a set of activities from A to J. A has got one particular path and C other path. We need to balance these tasks to workstations so that equally every workstation the job is task is distributed. And we are going to discuss line balancing using this problem. The problem says balance the production line to achieve an output of 365 units per day. So the output here given is 365 units. Available production time is 8 hours with a 40-minute lunch break. So 8-hour shift and 40-minute lunch break is also specified in the problem. Use longest number of following task rule to select the task for the work center. So the data given are the output, the available production time, and the rule to be followed. And the other data is the network which shows the different task and the preceding successive task, and finally ending at the last task. So all these data are given. We are going to balance the workstation, balance the production line. And first we need to find the cycle time. To find the cycle time, we need to know the output, and we know the output as 365 units. And the total operating time available is 8-hour shift, 480 minutes. 8 into 60 is 480 minutes minus 40 minutes lunch break, which is 480 minus 40, which is 440 minutes. So that total cycle time is equal to 440 divided by 365, which comes to around 1.2. And to find the total work content, we are going to use the addition of all the task time. And A takes 1.1 minutes, B takes 0.4, C takes 0.5, and so on. We are going to add up all the task time, and we are arriving at value 6.8. So 6.8 is the total work content for this particular project. And so we know the cycle time of as 1.2, total work content as 6.8, and minimum number of workstations, we know the formula, with this total number of work content divided by cycle time. So 6.8 divided by 1.2, which is 5.667. And we can't have 5.667 as a count, so we'll take it to the next integer, which is 6 workstations. So we have identified that this particular project needs 6 workstations, and 6 workstation, and each workstation the cycle time is going to be 1.2 minutes. Now we are going to assign the jobs task to the workstations. And we have the rules. Rule is following task rule, and anyways we are going to assign the first task, which is A. 1.1 is the task time for A. So workstation 1, A is assigned first, and the remaining time is 0.1, and we'll check whether the next set of active tasks has got processing time of 0.1, and if we check, B is 0.4, C 0.5, and D 1.2. so we cannot assign any other task in workstation 1, so we are leaving the task as it is with idle time of 0.1. And in the next workstation we are going to assign the next task, and in the next task we have 3 tasks equally, it can be assigned B or C or D. We are going to use the longest following task rule and identify which task has got longest following task. And B has got EGIJ 4, C has got EGIJ 4, D has got FHIJ 4. So Here this particular rule cannot be applied because all three has got similar number of following tasks. So the next, even though in the problem it is specified that following task rule should be used, here we cannot use that, so we use the other rule, which is longest processing time rule. So among B, C and D, we are going to check which task has got longest processing time, and 1.2, which is the largest, and it is D. So we are going to assign D task to workstation 2, and when we assign D, it takes 1.2 minutes to complete this task. So idle time is equal to 0 because the workstation cycle time is 1.2, D has got task time of 1.2, so idle time is 0. And next we are going to assign the next activity among B and C, either B or C, but B and C has got equal number of following tasks. So we have to check the other one, which is longest processing time. Among B and C, C has got longest processing time of 0.5. So we assign C to this workstation first, and the remaining time is 0.7. So after assigning C, we have a remaining time of 0.7. So can we assign B? Yes, because B has got task time of 0.4. We can assign B to the workstation 3. Even after assigning, we have a remaining time of 0.3. Now the next set of tasks, which are F and E. We are going to check whether we can assign F or E to workstation so that we can assign it perfectly without any idle time. And first we need to check the rule, longest following task rule. F has got 3, E has got 3, so similar number of following tasks. So among F and E, we have to assign based on processing time, so task time. So longest task time is F. F is 0.4 and E is 0.3. So we have to assign F. But in this workstation, we have remaining time as 0.3. We cannot assign F because it should be accommodated in a workstation where it is able to operate for 0.4 minutes. So here we cannot assign. Rather, we can assign E so that E takes 0.3 minutes, and this workstation, if we assign E to this workstation, it is perfectly balancing and without any idle time. So we assign E here. And for the next workstation, we have to assign F. F takes 0.4 minutes and the remaining time is 0.8. So F is assigned to workstation 4 first. And in the next, among the next set of tasks, we have H and G. We have to assign H or G, and following task, both has got 2. And if you look at the processing time, H has got 0.8 and G has got 1.1. We have to assign G because it is the longest processing time task, but the workstation 4 has got remaining time of 0.8. If we accommodate H, we can perfectly balance workstation 4. So we are going to assign H to this workstation 4, and we are assigning so that the idle time is 0. Perfectly balanced workstation. And next is we are going to assign G to this particular workstation. G takes 1.1 and remaining time is 0.1, and we are going to check whether I is active task which has got 0.1. No, I is task time is 0.7, so we cannot assign I to workstation 4. So idle time is 1.1 in workstation 5, and we have to assign I to the next workstation 6. I is assigned 0.7, remaining time is 0.5, and J is assigned next 0.3, and idle time is 0.2. So if we look at all the workstations, most of the workstations are assigned without any idle time, perfectly balanced workstation. Only the other workstations, workstation 1, workstation 5 and workstation 6 has got very minimum idle time of 0.1, which is acceptable for line balancing. So this is a somewhat perfectly balanced line, okay. and we are going to ascertain whether the efficiency is up to the mark, up to the standards which is expected by the company. So line efficiency we are going to calculate. So line efficiency is total work content divided by number of workstations into cycle time, and total number of work content we know it is 6.8, and number of workstations is 6, and cycle time is 1.2. So by a small calculation we find that the line efficiency is 94.45, which is very good efficiency. Efficiency of more than 90% is good, and this and it is, the line is equally balanced, and the efficiency of the line is also very good. So this is a perfectly balanced line. So this is all about line balancing. Thank you very much.